Alright friends, here's part 2 of the video. We just left off and we're just about to do number 5. So on number 5, again, I'll give the answer first to make sure you have it done. Again, whenever you're confused or whenever you're not sure, always give a guess anyway, just for practice on the AP. So the answer for number 5 should be B. If you got it right, go on ahead. Otherwise, here we go. Here's number 5. So number 5, the graph up here is G, and it tells us that there's horizontal tangents at x equals 4 and x equals 8, and that's not really terribly important, but it's cool they told us. It looks like that anyway. So at x equals 4, I could draw a tangent line that has a slope of 0, and at 8 the same thing, but I don't know if we really need that, but we'll see. F is going to be an integral, so what is the value of f prime at 4? So why don't we do like before? Why don't we find the derivative first, and then we'll plug in 4. Okay, if I want to find the derivative of f, that means I'm going to take the derivative of an integral, which is going to destroy the integral. But let's do that check one more time. Number on the bottom, x or function on the top. I'm going to be using chain here. So the derivative over here of f prime of x should be root x gets plugged into t. I should get g of the square root of x. So the square root of x function gets plugged in for t. And that looks a little strange, but we're doing it right. This is FTC. But we do have to multiply by the chain, which, just like we did on the other problem, just simplifies to 1 over 2x to the 1/2. All right, let's take that answer now. Let's evaluate that at x equals 4. This becomes g of the square root of 4 times 1 over 2 times 4 to the 1/2, which is also the square root of 4. This becomes g of 2 times 1 over 2 times 2. Now, to find g of 2, we're going to have to go back to our graph, because the graph is of g of x. So look at the graph at x equals 2, right over here. And g of 2 is 2. The y value is 2 times 1 over 4, 2 over 4, or final answer, 1/2. Number 6. The answer for number 6 should be A. How'd you do? Shall we go over it? Let's try it. Here, big f of x is an integral. And the question is asking for the second derivative at x equals 1. So let's find the first derivative, second derivative, and then plug in 1. I'm taking the derivative of f, which is going to be an integral. So FTC, the check is, number on the bottom, check. X or function on top, yep. Chain rule, you bet. All right, let's just start with f prime. F prime of x should be, integral goes away, and the x squared gets plugged in for all the t's. There's a t on top and there's a t on the bottom, so watch out for that. How about the square root of, not t squared, but x squared, squared plus 3 all over 2 times t, or x squared. And by chain, let's multiply this by the derivative of x squared, which is 2x. All right. Well, we're going to have to find the second derivative, but I think I want to simplify this a little bit more first. All right. Inside the radical, I get x to the 4th plus 3. And I do notice I have an x and an x on the bottom, so I can take 1 away. And the 2's also divide out and cancel. Sweet. So I should be just left with a single x on the bottom. Okay, that's f prime of x. So now we need to find the second derivative. Ooh, quotient rule. My favorite. Here we go. F double prime of x is, all right, low d high. How about low times the derivative of high? Now, before I do derivative of high, maybe I should rewrite the high as x to the 4th plus 3. Square root means the 1/2 power. All right, so this is going to be low times d high. d high is 1/2 x to the fourth plus 3 to the negative 1/2 by power rule times chain would be 4x cubed. Make a little space here. That's low d high. Let's do minus high, which is x to the fourth plus 3 to the 1/2. D low is just times derivative of x, which is just 1. All divided by low squared, which is x squared. Now, there's a lot of simplifying we could do here first if you want, or if you want, you can just plug in 1. I'm going to do a little bit of simplifying first, but not too much. I see I could probably do a little bit of factoring because I have the same parentheses here, the same factors, which would be good algebra, but since we are going to be plugging in a number here, I don't think we have to do that. But I do see I have some halves, I have some 4s, some x's, and a 1 here. So I'm going to simplify all that first, and then I'll plug in the numbers. All right, here we go. F double prime of x should be, well, the x and x cubed becomes x to the fourth. The 1/2 and the 4 becomes a 2. And then I get x to the fourth plus 3 to negative 1/2. That's the first term. Minus, well, nothing much happens in the second term except the 1 goes away. And there's my second derivative. Again, I could probably factor it and it'd be really helpful, but I think I'm just going to plug in 1 right now. So let's evaluate this at x equals 1. Here we go. This becomes f double prime of 1 is 2 times 1 to the fourth times 1 to the fourth plus 3 to negative 1/2 minus 1 to the fourth plus 3 to the positive 1/2 all over 1 squared. All right, 1 to the fourth is just 1, which is nice on all these. This just becomes 1, this becomes 1, and this becomes 1. And if you notice inside the parentheses, these are all going to be 4s to either the 1/2 or the negative 1/2, which is either a 2 or 1 over 2. So watch what happens. On the bottom, 1 squared is also just 1. Okay, this becomes 2 times 1 times 4 to negative 1/2 is 1 over square root of 4, or 2, minus 4 to the 1/2 is just 2, all over 1. 2 times 1 times a half is just 1, minus 2 over 1. And my final answer. That's why it's A. Good job. Let's take a look at the free response question. We'll start the first one, and then maybe we'll finish the rest of it in another video. Okay, these I definitely want to walk through first, instead of just giving the answers out. So let's walk through these guys. Check and see, this is a graph of f, and it's on a closed interval from negative 3 to 5. That makes sense. And we're going to define g as this function, the integral of f. So I know I'm probably going to be using FTC in some way. All right, so part A says, can you find the derivative of g at x? Derivative of g is going to destroy the integral. Let's do the check. Number on the bottom, x or function on top, chain will be required here. But we don't have to plug in any numbers at the end. We're just going to find the derivative. All right, so how about g prime should be integral destroyed. X or function gets plugged in for t. This should be f of 2x minus 1. And by chain, we're going to multiply by the derivative of 2x minus 1, which is 2. Or, final answer, 2f of 2x minus 1. We don't have to do anything with that. We don't have to plug anything in. We just want to find the derivative. But for part B, we do want to plug in a number. So let's take this answer that we got of 2 f of 2x minus 1, and let's evaluate that for x equals 3. All right, this becomes 2 times f of 3 is 2 times 3 minus 1, which is 2, times the f of 6 minus 1 is 5. All right, I need to find f of 5. So go back up here in the graph, and when x is 5, your y value is 1. So I get 2 times 1, final answer is 2. All right, I'm going to finish part C and question number 8 in my last video.